Hello, everyone. This is John Bonjean, the State GIS Coordinator for NRCS Idaho. And I'm shooting a short video here as a replacement for our November 28th Lunch and Lidar seminar, which was marred by technical issues. So I'm recording this video as a kind of fill in for that and also a reference for people to come back to if they have questions about utilizing Lidar and ArcGIS Pro. If you're unfamiliar with LiDAR, it's a remotely sensed technology with gathers elevation data on the landscape, and it's delivered as derivatives to us, usually in the form of very high resolution raster data sets. If you're not familiar with what a raster data set is, it's just gridded information. All of our imagery and many other products are raster data, and it's really just an image product. If you do any kind of processing with raster data, not just LiDAR, but other elevation data sets or imagery analysis, you're probably going to need to enable the Spatial Analyst license in ArcGIS Pro. Spatial Analyst is an extension module for the program, and it's not enabled by default. So you'll need to grab a license for that to enable many of the tools we'll be using today. If you're unsure if you have it, or you're pretty sure you don't, to enable that extension, I'm going to go up to the project menu up here in the upper left, click on that. I'm going to come down to my licensing menu item here. It looks like that was where our last was, so it defaulted to it here. I'm going to wait for that to catch up here. It shouldn't take too long today. But once it catches up, it'll show me what my current extensions are. And I can scroll through here, and I can see that I do have Spatial Analyst license. But if I did not, I would want to come down here and select Configure Your Licensing Options and click on that. Once again, it's going to take just a minute or two to catch up and reach out to the server and find what I have enabled. I'm going to scroll down here and find Spatial Analyst. And because I have a license, this box here is already checked. But if I didn't have a license, I would just add a check in that box, hit OK, and wait for it to grab the license, and then I'd be ready to go. And this is a step you only have to do once, or perhaps again if you upgrade to a newer version of ArcGIS Pro. But once you check out that license, it's going to stay checked out until you either upgrade or uninstall, whatever. So in this case, I'm going to cancel, and I'm going to go back to my ArcGIS Pro project. So the first thing we need to find out accessing LiDAR is, does my project area have LiDAR available? Unfortunately, Idaho does not have border-to-border LiDAR coverage. It's getting better all the time, but there are currently some areas where there's large gaps in the data. We do have access to some resources to find out if we have LiDAR in our area of interest. One is the Idaho LiDAR Consortium. I have a link here in the agenda document here. I'll click on that. And that takes us to the homepage for the Idaho LiDAR Consortium. We have over here on the left a map for existing data. So I'm going to click on View Existing Data, and that'll tell me what's available through either download or the LiDAR service. The LiDAR service sometimes is a little bit behind time-wise from what's available in download. It does take them a bit of time to add stuff to the service, but usually it's pretty up to date. So this is our map showing our availability. If I click over here on our context menu, open legend, we can see our legend gives us a little bit of information, but it's not a super thorough legend. We see that the areas in red are 2023 data or the current year, and then all the purple areas are past year collections. So I'm going to minimize that again, and I'm going to zoom into an area on the map. Let's Zoom in here, and if my area of interest was here, I would see that the data set I want is the East Fork Salmon River. Like I can then scroll down here and look through these data sets and find the download that I need. Now, you only have to do this if you want the data stored locally or if you're looking for an area that is too large to process from the Lidar service, which we're going to look at after this. But you would scroll down here if you wanted the East Salmon River, and it's a lot to scroll through. You can see it's not super organized, but when you find your data set, you would just click on derived products and data if you want the derivative products. And that data is not available. Bad example. So that would be another reason to go to the service. If their data is not available, there are contacts you can work through to try to find out why it's not available and if there are other avenues of getting it. But I'm going to assume that the project I want is covered by the service. So I'm going to minimize this and return to my ArcGIS project. And this project currently doesn't have the service added. I've created layer files for adding the service, and they're located on the geodata drive on every field office server. So I'm going to add the data from there. You can go to add data and navigate to your F drive, or you can add the folder to your catalog over here on the right. I've already done it for the Boise server, but if I hadn't, you would just right click on folders and select add folder connection, navigate to your F drive and add that folder. So to find that Lidar layer service, or the layer file for the Lidar service, I'm going to expand the F drive. I'm going to navigate to geodata. I'm going to go to elevation, and you should find a folder in there named Idaho Lidar Image Service Stream. I'm going to expand that. Now I have two layer files in there. The .lyr file is an ArcMap layer file, and the .lyrx is an ArcGIS Pro layer file. If you are running ArcGIS 3.0, you'll be able to use the ArcGIS Pro layer file. If you're still using ArcGIS Pro 2.9, you will not. But that's okay because the ArcMap layer file will work just fine for you and pull in the service just as well. So add whichever one's appropriate for the ArcGIS Pro version you have. Right click and select add to current map. It might take it a second to display. Especially if you're looking at a map statewide like I am here. Eventually it will get there and we'll see our LiDAR service for the state of Idaho. There we go. And we see we got pretty good coverage so far. Like I said, there are some significant gaps in the data, but it is getting better every day. So in my project over here, I've already added an AOI. So I'm going to right click on that and zoom to the layer. And we can see my AOI and my LiDAR service has gotten where the display is not very informative here. Oh, there it goes. It updated. If I look at the symbology of that service, it came in with digital range adjustment already selected. It might default to data set, in which case we'll take a look at what that looks like. It doesn't give me much information. The reason for that, the statistics are being calculated on the fly as far as what value range my display stretches this color scheme over. And when I select the entire data set, it doesn't always show a lot of detail at the local level. What dynamic range adjustment does is it changes the statistics of that value range here to just my local view. So this color band here is stretched only over the values in my current display, showing me much more detail at the local level. I'm going to close that and come back to my Lidar. So that's how to add the basic Lidar service to your ArcMap project. Next, I'm going to talk about processing templates. Processing templates are prearranged derivative products that would calculate on the fly as part of the service. To access them, I'm going to right-click on my Lidar layer. I'm going to go to Properties. And if I'm not already, I'm going to select this Processing Templates tab down here. Up here where it says Processing Template, I can select this drop-down and select which template I would like to display. We see there's a few options here. We can do aspect, a hill shade. We can convert our elevation in meters to elevation in feet. We can show a shaded relief. We can do slope in either degree or percent rise. Just to demonstrate real quick what this looks like, I'm going to select the hill shade and click OK. And there my display has changed to the hill shade with no processing required on my end. Pretty instant derivative product right there. So let's talk about extracting the data from the service. Most services aren't set up for straightforward downloading, but there are ways around that. We're kind of going to use some of those spatial analyst tools to work around some of the limitations of the service. Before I do that, I don't want to download the Lidar or the hill shade. I want to download the raw DEM. So I'm going to go back to my processing templates, and I'm going to change that to none and select OK. Oh, let's try the other none. Now, as you can see, there's some bugginess in the service still. See if I can get my shaded relief. Now, to avoid these bugs, I'm going to remove the Lidar service and I'm going to add it to the current map again. And I reset what I'm pulling. And there's my regular elevation data set again. So I'm going to switch from my catalog here to geoprocessing. And if you don't have your toolbox or your geoprocessing panel open, you would come up here to analysis and just select tools and it'll open that panel for you. We see we got a lot of tool sets here. The one we're interested in today, again, is Spatial Analyst, the tool we enabled from the project menu. I'm going to click on the little context to expand it. I'm going to scroll through there, and for this purpose, I'm going to select the math tool. This may seem counterintuitive, but I think it'll make sense once we get into this. And I'm going to select the plus function. So on my input raster, I'm going to select my image service. And for input raster or constant value 2, I'm just going to put in 0. Now I'm going to select my output raster, and I'm just going to select, I'm just going to put it in my project folder here. See if I can overwrite my DEM AOI. Now I have an error message here. It's saying that I'm going over the size limit of the Lidar service, of the image service. That's probably because of my environments. By default, most tools are going to go to the extent of the full data set, which, as we saw earlier, the data set covers the whole state of Iowa. That's too much to process over an image service. But for an AOI like this, I should be able to process my local area. So I'm going to go to environments, and I'm going to go to my processing extent. And the default, like I said, is going to be the entire data set. I'm going to change that to current display extent. And let's go back to our parameters. And we see that we don't have an error anymore. I do have a warning, and it tells me that I'll be overriding my output raster will be overriding an existing raster data set, but that's okay by me. So I'm going to select all that and click run down here and wait for my results. Takes a few minutes to process, but generally it will work fairly quickly. Of course, that will depend on the size of your AOI as well. So I now have a DEM for just my local area, and we can see the range of values is a little different to what we had before. I'm going to remove this one now, the Lidar service. And we can see that what I've downloaded is just the local to my AOI. It was the current display extent. And now I have local data that I can use for analysis of my project. So that's how you would extract LiDAR from the ISU LiDAR service. Let's talk about creating hillshades and some other visualization methods. A hillshade is a derivative data that simulates what the landscape would look like under certain sunlight conditions. That's again in my spatial analyst tools. So I'm going to go back to spatial analyst. It's going to be in the surface tool set. And to do a hillshade, I'm just going to select hillshade. For my input raster, I'm going to select my DEM. I can select what I name my hillshade. I'm going to just go with what's default there and overwrite my old one. You can change these values if you know what you're doing with azimuth and altitude, but you'll get some weird results. The defaults work pretty well. And the Z factor is something you can play around with. A Z factor of 1 will just simulate real world conditions. If you're in a low relief part of the state and you just want to kind of exaggerate the features on the ground, you can up that some. And it's going to vertically exaggerate whatever is out there in the DEM. For this demonstration, we'll leave it at 1 and click run. And my hillshade is completed there. And it looks very similar, unsurprisingly, to the hillshade we had from the service before. We can do some further tricks for visualization to kind of really get a different look at the landscape out here. One thing we can do is drape the imagery over the hillshade. There's different ways of doing this. You can put the imagery over the hillshade or the whole hillshade over the imagery, vice versa. Different people do it different ways. I generally put the hillshade underneath the aerial, so I'm going to drag it down here below my aerial. I'm going to turn on my aerial imagery. And we lost our hillshade, but if I highlight my imagery and I go to the imagery tab, oh, excuse me, if I go to the view tab, which tab is it? Tile layer? There we go, tile layer. Because it's a streaming service, it's got the tile layer tab. I'm going to change the transparency here, and we'll just start at 50%. That's usually a pretty good value. You can darken the imagery or lighten the imagery as you see fit, but 50% will give you a pretty good starting point. And you can see now that we can see aspects of our hillshade through the imagery, and gives us a little different perspective on the landscape out there. That's a useful tool. We can leave all this on, and if I wanted, I could drape my soils data over the hillshade and see what kind of soils I have over what kind of terrain. In this case, I've already set up the symbology and labeling of my soils. We won't go through details of doing that today. I think Eric Mueller's videos cover a lot of that, but it's a little time consuming, but you can save it in your project. And we got a nice looking general map of our AOI here. So we can take this even further. If I want to get an even different view of my relief here, we can generate contours. So let's take a look at doing that. I'm going to turn off my imagery and hillshade, and I'm going to turn off the soils as well. And I'm going to turn the DEM back on. Contours are a tool set in, once again, you guessed it, Spatial Analyst. So I'm going to, it's also in the Surface tool set, so I don't need to go to another tool set in this case. I'm going to select Contour. And for my input raster, I'm going to select the DEM. We can create the output feature class of whatever we want to name it. Once again, this is, I'm going to override my old data set, but we can create whatever we want. For the contour interval, I believe my data is in meters here. For the purpose of the demonstration, I'm going to put in 25. Base contour will start at 0 so that our contours are, regularly 100, 125, 150 type numbers. I'm going to leave my Z factor at 1. Contour type here, I'm just going to do contour. And you can establish a maximum number of vertices per feature if you just want a lighter data set, but that's really the only reason to do that. So I'm going to go ahead and click run here. 25 meters didn't give us a ton of contours on this AOI, but I can turn my hillshade on. And it just gives me a little bit more information on interpreting the surface of that Lidar, of that DEM. So that's our presentation for today. If you have further questions on utilizing Lidar or the services or creating derivatives, once again, I'm John Bonjean, State GIS Coordinator. You can find me on Teams or through email. Thank you. Have a nice day.